So in this exam style question, we're told that when an uncharged capacitor is charged by a constant current of 5.5 microamps for 60 seconds, the potential difference across it becomes 8.0 volts. So I'd like us to start just by calculating the capacitance of the capacitor. So this is fairly straightforward, but with one little twist. So the first thing we need to do is write down the relevant equation. So here we just need to remember, well, how do we define the capacitance of a capacitor? Well, its capacitance is just the charge on the capacitor divided by the potential difference across the capacitor when it has that charge across it. So that's C, capacitance, is Q charged divided by V, potential difference. There's one thing we have to do here though, which is we don't actually know the charge on it. We have to work that out. Now we know normally that charge is just the area under a current time graph, but here we're told we've got a constant current, which means that we can actually use a very simple definition of charge, which just charge is the current flowing in your circuit, when that's constant, I, times by the time your circuit has been on for, which is in this case 60 seconds. So our charge is going to be given by the current times the time, and then we have everything we need to actually go from here. So we need to just start by substituting these things in. So we can have that C is going to be IT divided by the potential difference. And now we can start putting some numbers in. So that our capacitance is going to be, well, the current, which is 5.5 microamps, that's times 10 to the minus 6 amps, times the time that we're running our circuit for, so 60 seconds, all divided by the potential difference across it, which was 8.0 volts. Now, units wise, we can cancel off this amp and second and volt to get our unit to be farads, which is what we'd like. But we could do something else. So there's no real reason for us to actually use this as 10 to the minus 6 here. We could bring that 10 to the minus 6 out to here and leave our answer in microfarads, which would make more sense. So just to write that out again, we're going to do 5.5 times 60, all divided by 8.0, and our answer is going to be microfarads. Or we could leave it as times 10 to the minus 6 farads. Where do we go from there? Well, we just need to go through and do this calculation now. So we do that, 5.5 times 60 divided by 8.0, it's going to be 41.25. 41.25 microfarads. We should only leave our answer to two significant figures because that's the level of precision all the rest of our answers have been, all the rest of the inputs we're putting into this equation have been given to. So that means we should leave this answer as 41 microfarads to two significant figures. And with that, we've calculated the capacitance. So the next thing they tell us is that this capacitor is charged using the circuit shown below. We're told that this battery EMF is going to be 12 volts, or 12.0 volts, I should say. And we're told its internal resistance is negligible, so we don't have to worry about that. We're told that we are keeping a constant current of 5.5 microamps. And they say that to do that, they have to, the resistance of this variable resistor is decreased steadily as the charge on the capacitor increases, which makes sense. We know that as the...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.